Welcome to a help video here on 3B7. This video is going to pick up with question number 12. And question number 12 and the ones that follow it are dealing with this nuclear symbol format right here. Nuclear symbol format, by convention, puts the mass number in the upper left-hand corner. The mass number symbolized by the letter A, or abbreviated by the letter A, tells the total particles in the nucleus. That's how many protons and neutrons it has. Then a 22 goes right here in the lower left-hand corner. That is the atomic number, letter Z. And that tells us how many protons the nucleus has. And if it's a neutral atom, the protons are positive, so it must have 22 electrons as well, offsetting the number of positive protons because electrons are negative. So this 22 right here, we should also find on the periodic table of elements because all titanium should have a 22. And there it is, 22. All titanium atoms, by definition, have 22 protons in the nucleus. This 4788 is the average mass of the naturally occurring isotopes of titanium because not all titanium atoms have to have the same mass. They all have 22 protons, but they can have different numbers of neutrons, giving them different masses. And that's what we call isotopes, different forms of the same atom that vary in numbers of neutrons, giving them different masses. So this 4788 is the average mass of the titanium isotopes, and that average mass is called the atomic mass. All right, here we go. Number 12, what is the atomic number? That's the atomic number right there, 22. What's the mass number? Oh my gosh, there's the mass number right there. It's 48, letter C. How many neutrons does it have? Well, if it has 48 particles in the nucleus and 22 of them are protons, the rest of them are neutrons. 48 minus 22 is 26. Again, you can always find the number of neutrons by, if you know the mass number, subtract from it the atomic number. 48 minus 22 is 26. How many electrons would the titanium ion, and in this case it's a 4+ ion, how many would it have? Well, we know that the number of protons and electrons start off equal for an atom because all atoms begin neutral. So that means if there's 22 positive particles, it must start off with 22 negative particles. If it's 4+, it now has 4 more positives than it does negatives. So we have to take away 4 of the negatives. That would leave it 4+. And that would be down to 18. 22 minus 4 is 18. Letter A. Does it make sense that titanium would like to lose 4? Well, here's titanium right there. It starts off with 22. If it loses 1, it would have 21. If it loses 2, it would have 20. If it loses 3, it would have 19. If it loses 4 electrons, it would have 18, just like argon. Titanium wouldn't become argon because what you are depends on how many protons you have. We're not talking about losing protons. We're talking about losing electrons in chemical reactions. In order for the titanium atom to transmutate into the argon atom, it would have to have 4 protons break off the nucleus and fly away. But if titanium lost 4 electrons, it would have 18 just like argon, and it would be chemically stable because the noble gases or inert gases have the same numbers, or the noble gases all have stable outer levels of the duet, satisfying the duet rule if it's helium, or the octet rule if it's neon, all the way down the line. How many nucleons? How many nucleons would this thing have? Well, we already know nucleons are particles in the nucleus. That's the mass number. We follow the arrow up. That would be 48, letter C. What's the correct hyphen notation for the nuclear symbol written above? The nuclear symbol, hyphen notation, has the element's name or symbol first with a hyphen followed by the mass number. So I go back up. The mass number is 48. So I could write Ti-48, or I could write the symbol out with the name. And you're like, well, how do I know what the name is for that element? How do I know what Ti is if I want to write the name? You have a periodic table. Look at it. Ti is titanium. So it would be titanium-48. Why don't they write titanium hyphen 22? Well, when we use hyphen notation, they're assuming you have a periodic table of elements to look up the atomic number. That's when you use hyphen notation. Hyphen notation is just trying to tell you the mass number of the atom they're talking about. There could be a titanium 49. It's still titanium. It would have 22 protons. But if it had 49 in the nucleus, 49 minus 22 would be 27. I almost said 47. 49 minus 22, that one would have 27 protons. Titanium 48, on the other hand, would have 40. Let me try that again. Titanium 49 would have 27 neutrons, 22 protons. Titanium 48 would have 22 protons and 26 neutrons. So they're varying in numbers of neutrons, not in numbers of protons. All right, next question. Which of the following could be an isotope to titanium 48? Well, the isotopes are atoms of the same element, so they would have the same atomic number 22, but a different mass number, a mass number different than 48. So titanium 49 would be an isotope. Titanium 49 would have 22 protons and 27 neutrons, 22 protons. It could also have less than 48 total particles in the nucleus, but it must be a different number than 48. So we're going to look for something with an atomic number of 22. Can't be this one. This one has an atomic number of 21. This one, in fact, is not titanium. If you have an atomic number of 21, you're scandium. You can't put titanium in here. This one has a 21 in it. It can't be that answer because 21 is not titanium. 21 is scandium. It can't be letter B. Letter B has a 21 down here. 21 is not titanium. It's scandium. It has to have a 22 to be a titanium. And for it to be an isotope, it still has to be titanium. Just a different mass number, a different number of neutrons. This one right here is titanium. It has a 22 there. But its mass number is still 48. Isotopes have a different mass number. So it's not letter D. Letter E does have a 22, so this one has a possibility. Isotopes have the same atomic number. But we need a number different than 48. This one has a different number. It has 47. Letter E is an isotope. Same atomic number, different mass number. In other words, same number of protons, different number of nucleons. Another way of saying that, same number of protons, different number of neutrons. This one has 25 neutrons. This one has 26 neutrons. 48 minus 22 is 26 neutrons. This one only has 25. It can't be letter AB. 23 in the lower left is not titanium. It's vanadium or vanadium. This one's not titanium. Cross it out. That's vanadium. 23 is vanadium. So if letters D is not an isotope, what is it? Isotopes, again, different number here, same number there. What is the one that has the same number? Same number. Oh, yes. Those are called nucleides. Nucleides are atoms of the same element characterized by having the same number of protons and neutrons. So on number 19, they're asking us, which one is a nuclide to 2248? Letter D is. They have the same everything. Nucleides are like identical twins. Same everything. Isotopes are like fraternal twins. A lot alike, but a little different. That takes care of 12 through 18. Let's take a look at the next question, number 20. Titanium 4+ has the same number of electrons as all of the following, except which one? Titanium 4+ has the same total of electrons as every one of these answers, except which one? Well, how many electrons does titanium 4 plus have? In question 15, we learned titanium 4 plus has 18 electrons. Where did I get that? 22 protons is what it starts with, so it starts with 22 negatives. But if it's now 4 plus, it means it lost 4 negatives. 22 minus 4 is 18. So in this question, we are looking for which one of these answers does not have 18 electrons. Does Cl minus have 18 electrons? Well, Cl minus, I have to look on the periodic table and I would see chlorine has an atomic number of 17. So if it's 1 minus, if it has an atomic number of 17, then it has 17 protons. If it has 17 protons, it starts with 17 electrons. If it's 1 minus, it's gained a negative electron. 17 and 1 is 18. Would it make sense that chlorine would want 18 electrons? Chlorine starts with 17 protons, therefore it starts with 17 electrons. If it gains an electron, it would have the same as argon. Argon's chemically stable. Yes, Cl minus, the chloride ion, makes sense. What about argon? Well, we already know argon has 18 electrons because it has an atomic number. That is not an ion. That is an atom. Argon starts with 18. What about potassium ion, K+? Potassium starts with 19 protons, so it has 19 electrons. If it's plus, it lost a negative. That's leaving it with one positive particle, one more proton than a negative particle, the electrons. So when you're positive, you've lost electrons. 19 minus 1 is 18. 18 is the same number as titanium. Would it make sense that the potassium ion wants to lose 1, or the potassium wants to lose 1 and become the potassium ion? If it starts with 19 and you lose 1, it has the same number of electrons as argon, which is chemically stable. Yes, potassium would certainly love to become +1. What about scandium? Scandium starts with 21 protons, or has 21 protons, so it starts with 21 electrons. If it becomes 3 plus, plus means it lost electrons to leave it plus. It starts with 21 protons, 21 electrons, 21 positives, 21 negatives. To have more positives, you have to lose negatives. So 21 minus 3 would leave it with 18 negatives. That's the same as what titanium has, 18 electrons. Does it make sense that scandium would want to do that? Certainly. Scandium starts with 21. If it loses 3, if it loses 1, it would have the same number of calcium. If it loses 2 electrons, it would have the same as potassium. If it loses 3 electrons, it would have the same as the chemically stable argon, which is what it seeks to do. Our last one, chromium 2 plus. How many electrons would chromium 2 plus have? Plus means it's lost electrons. It starts with 24. If it loses 2, it would only have 22 electrons, not 18. Letter E does not have the same number of electrons as titanium. Who does it have the same as? It wouldn't have the same number as titanium 4 plus. Titanium 4 plus has the same as argon. If chromium loses 2, it would have the same as titanium, not titanium 4 plus. We'll stop here at question 20 and pick up on our next video with the true-false questions following.